So, Brad, do you want to take a minute or two to share any comments on that, or just if people want, they can contact you later?
Yeah, sure. Basically, it was a really good discussion. I made some great notes. I have more ideas than I sort of have time to follow up on, but we'll work our way through them. So, I mean, we had made some suggestions about whether there's parallels drawn from other organizations that have gone through similar developments, like Society of Wetland Scientists, and then we also got into Society for Ecological Restoration. They've published some materials that might be interesting. George Kelly gave us an interesting idea on a framework within which we could then operate, which would lay out a bit of a roadmap for us. We had talked about some technologies. We talked about the idea about using interns. There was generally, that we found out that a lot of software we can make available, we can get relatively cheaply as a nonprofit, which would assist some interns perhaps. We've just got a lot of really good ideas, and I think we're going to have another call today.
Already on my first call.
We're going to have another call.
Yes.
I'm doing this. I can't really.
Sorry, am I talking over somebody?
No, we're good.
Anyway, so we've got a bunch of ideas. We're going to do some follow-up. We've had some really a lot of support for trying to expand the website and use it to do some more advanced use with the website. So anyway, so that's kind of the gist of it. So I think what we're going to do is reconvene a smaller group and talk about priorities and figure out where to go specifically, because I think we want to figure out a way to have an impact in the short term, but we don't have a lot of time and money to throw at it. So so I think what you're going to see is some actions that are going to be in the short term, and then sort of hopefully gain some support and momentum in our efforts in the future. So that's where we are.
Mr. Greg.
Good morning.
Are you ready to share this morning?
We'll see. We're going to talk. Yeah, we're going to talk about calculating or delineating watersheds using DMs, QGIS, and with TAUDEM. I know a lot of times we'll use stream stats to pull drainage areas. Often, well, not often, but in Wyoming and Texas, stream stats isn't available. This is one option for doing that. Also, it may be actually faster than using stream stats if all you're looking for are drainage areas. So we're also using this demonstration to play with Adobe Premiere. So we've made a small video kind of show all the steps. So I'll get my screen shared and see what happens. About 6.5 minutes, we'll just let it play through. And then if you guys have any questions, feel free to hit me up. We're going to show you how to use TAUDEM and QGIS to figure out drainage areas.
Thank you.
DEM, or digital elevation model, uses a raster to represent elevations. TAUDEM and QGIS can both be downloaded from the internet. They are both open source software. First, download all the DEM tiles. This information can often be found in public domains such as the NRCS Geospatial Data Gateway or the USGS National Map. Once you have all the elevation data necessary to delineate the largest of the drainage areas of interest, bring them into QGIS. It is important that all the raster tiles are in the same projection. For this example project, the project covers 2 UTM zones, Zone 14 and 15. To process the tiles that were in Zone 14 were projected to Zone 15, leaving everything in Zone 15. To combine the raster tiles or create a mosaic of the rasters, we built a virtual raster. The virtual raster was then exported to a TIFF for processing in TAUDEM. After TAUDEM is installed on your computer, you can run it using command prompt. There's a helpful PDF explaining all the steps necessary to run the tool on TAUDEM's website under documentation. We're going to remove all the pits on our data set, creating a hydrologically correct raster. I changed the name of the output raster to save me some typing in the remainder of the commands. The next step uses the hydrologically correct elevation model to calculate flow directions. The DH shows that TAUDEM is looking at each pixel surrounding a single pixel and showing which direction water is expected to flow. To calculate D8 area, we will now use the flow directions and elevation raster to estimate how water flows through the system. For those of you familiar with ISRI products for delineating watersheds, this is similar to creating the flow accumulation raster. That is all we'll use TAUDEM for in this demonstration, but Tau can be used to calculate slope rasters, stream networks, calculate stream order, and measure the longest flow paths, and so on. Now we'll bring the 88 TIFF file into QGIS for further processing. The first step is making sure that everything is in the correct projection. Now we are going to do some raster math. Each pixel in this raster represents the number of pixels that are flowing into it. Because we are in meters and using a 10 meter DEM, we will multiply the pixel value by 100 to get the total area flowing into that pixel. We will then multiply it again by the value necessary to convert square meters to square miles. Now we have a raster that's pixel represents the drainage area in square miles of all the tributaries in our drainage. We are going to make some adjustments to the display of the raster to make it easier to see where we have data. Using the Identify tool, we can see that at this point, the drainage area is approximately 0.7 square miles, based on the 10 meter DEM. To process a number of drainages, we will use the Sample Points option in QGIS. Start by creating a shapefile and marking the points of interest. Now run the sample command to pull drainage areas from the raster. It is important that these points fall on pixels within the data. In this case, any white pixel that is being displayed. Now in no time at all, we have a number of drainage areas for the drainages that we selected. To help in using TAUDEM, my wife has created a batch file that automates most of the TAUDEM process. This has made the process more efficient, and we're excited to continue to develop it.
All right, so that was the video. Exciting times.
Greg, so how does this work so what's the value of this over something like stream stats?
Be faster so usually when you delineate a watershed and stream stats, it's going to process a lot of the data. Pretty much all the processing is already done using this. In this raster, I literally just click a point and have a drainage area.
Right. And then obviously there's some states that don't have stream stats yet, right? So
Right.
how would this work on a statewide basis for something like Wyoming? I think Shane's on the line. So
Yeah, I think it'd be possible so when you start putting together that much elevation data, it might be challenging to have one map that just works for everything. But I mean, it would be possible. It'd just be a large data set. And I think starting statewide, you'd want to use like the 30 meter.
What size watershed do you think would be the most reasonable that you could probably use this on? And then you'd have to go smaller, or else it's going to be too data intensive.
Let's see. I don't know, because this watershed here, I can't even remember. I think it's 100 square miles, so it's pretty decent size.
Yeah, so reasonable size watersheds. It's not just small watersheds, but it's probably not going to be, 1,000 square miles. It's probably going to be in a range of 100 square miles. Is that your thought?
Yeah, and well, in this one we use 10 meter DEMs. If we want to do the large watersheds, 1,000 miles, so just bump it up to the 30 meter DEM and be able to do that. You wouldn't get good resolution on the smaller watersheds in there, but any of the larger streams.
And maybe for a mini regional curve, we just do just choose where that mini regional curve was at. How available is 30 meter DEM data globally?
Globally, I'll have to look. For the US, I can get it anywhere. I can get pretty much 10 meter for anywhere in the US. I don't know about globally.
Yeah, I'm just wondering if we had some opportunities in other places, if we could be able to pull this up, like if we're working in Peru or something and can't find good data down there, could we pull it in? So
yeah, I think some of the elevation data is processed on satellite, so there may be something available.
Greg, it's Brad. Question for you on areas. I know that in some other discussions we've been having about gross versus effective. So if you're using a 10 meter DEM, then are you going to have issues on really, really flat drainage areas where we have very little relief?
I think it really depends on how big the watershed you're looking at. I don't really foresee that as being too much of a problem. I guess your lines might not line up perfectly, but your drainage area should be close. You can even see well, I guess you can't see it anymore, but the streams don't line up exactly where the streams are at, but it puts you close.
But will this approach identify those areas of sort of closed drainage basins within a larger watershed?
Yeah, I would think so.
Oh, okay, cool.
Yeah.
Interesting. Thanks.
Yep.
how would we, can you think of any ways of, other than just manually getting the watershed and delineating it for accounting for places where we have cross basin diversion transfers, or if we just have large catchments that don't allow any drainage because they're just large evaporative farm ponds or something like that? Can you think of any way that you could incorporate this, or would you just have to account for it and do it manually?
In some cases, you have to, I mean, if you have big catchments or whatever, maybe culverts that move water across basins or whatever, you can actually manipulate the DEMs. It'd be a pretty manual process.
Okay. Good.
Yeah.
Any other questions for Greg?
Thanks, Greg.
Yeah, thank you.
Thanks, Greg.
Absolutely.
Thanks, Greg.
I like the video too, Greg. That's kind of cool.
Yeah, Andrew's been playing quite a bit with the Premiere. We're trying to figure it out. A lot of options. Yeah.
Yeah, I did this one for the Ralph Hall project. followed Greg's advice. Dave.
And it worked out well for you?
Yeah.
Good.
Yeah, that makes the getting drain shades a lot easier.
A lot easier than doing the stuff in Texas or doing the stuff in Colorado, Luis.
For Texas, since we don't have stream stats there.
Yeah, we still have a number of states without stream stats.
And there's a lot of cool options that we're looking at with Andrew and me trying to get like weighted rasters, just showing precip and all sorts of stuff. We've put together, like flow debris models and that kind of stuff using raster math, and it's been kind of interesting.
Good. All right. Well, so we're going to move on. If people have questions, they can stick on the line. If we can talk a little bit about kind of what people have going on, if they're looking for a little bit of work or if they have anything that they need a little bit of help with